Hola, buenas a todos. Gracias por...
Good morning, everybody. Thanks for coming. We're now going to listen to Jacinto, who will tell us about DEVOPS, his daily experience at work, and he's going to tell us about his tricks as well when he has to encounter some challenges, and he will probably be talking a lot about Docker. If I will continue with him, please remember you can vote on the talks with the COVID system, and you may follow the duration of the talks. Miko seems to be winning so far. Thanks very much. Good afternoon, everybody. I'm going to talk about DevOps from the scratch to heaven or hell, my experience. Uh, DevOps, after all, is just a framework, a technology defined by agile and delivery value to the customer. And I want to tell you about my experience. I started without knowing nothing with DevOps, and and the state of the art in which I'm staying. This has been paradise or hell. Let's see. These are my coordinates. My name is Jacinto. I have studied the development of computer applications. I'm studying computer engineering right now, and I collaborate with Smart Iris Technologies. And you have my data, my contact data there. As I've explained, this is just one idea, and the idea is as follows: we have a master node, which is here, and then we have a number of nodes that connect to some sort of green environment. And we have it indicated with a Redis service, with a database, and they all communicate using the 0MQ messaging system. Once I proposed this, I said, oh, what a mess I've got myself into. Will I be able to get anything out of this? So finally, I decided to take on this challenge. I decided to go for it. Round one, we're going to install Docker, which is one of the environments that's very much used in DevOps right now in Windows. I have Windows 7, unfortunately. And the poor thing, it's elderly. I call him my legacy. Do we have tools to be able to work with Docker in Windows 7? If we look at the web page, we have the Docker toolbox that provide us some tools to be able to use Docker. And one of them is the Quick Start terminal. And when I go in, it starts executing itself and I find this bug. So I ask myself, what's going on here? So I try with Kinematic Alpha, which is another tool that allows us to boot up Docker. And I find I come to the same message. So I go into the VirtualBox and I have this screen coming up. So I propose something and I'm not going to be able to achieve that. I'm not going to be able to handle Docker. So I panic. But then you start to Google and you start searching Stack Overflow And then you see that Docker toolbox uses VirtualBox to virtualize, to make a virtual Linux to execute Docker with it. But this virtual machine must have the same architecture than the host. But my processor does not have the technology to virtualize that. And I tried with my Ubuntu 14.04 and I get the same error. So what happens at this point? I stopped thinking and I thought I'm not going to be able to achieve anything. But if I have a native Ubuntu, why will I not be able to execute Docker? I tried it and I installed Docker there. So round two, we'll try to do a hello world with Docker. And this is the environment. We're going to set up our Linux host and we're going to connect with our Docker machine. So our index is going to be very simple. We will connect to a port, generate a server that will send a request. And we do a log immediately in the Docker file. I install the whole library, the app, wherever it covers, wherever is suitable. So we execute, it generates the container. And once we're going to post it, it busts. And we look into it and I get into the conclusion we can modify the Dockerfile and we have heritage. We can inherit from a machine that's already there and we do not need to reinvent the wheel and we can add whatever we need. So we did the same thing. I tell the port of my Docker machine to connect with the port of the local machine. I can boot it. And from the local host 8888, I leave the message. And I tried the same thing with cool, and I got the same result. So we can connect to the Docker machine. And now we're going to add 0MQ. And we're going to have this scenario. We're going to have a server that will do a push, and the customer will do a pull. So in both, we're going to have a JS. What will the server be like? We're going to bind to 9,000 port and it's going to send a message every 2 seconds. Hello and a number. And our Docker file is also going to be inherited from node 6.9 and we install all the libraries needed. The RAM command, we've introduced all of the commands at once. And that's because a container is created only by every RAM. And it's a single layer with all of those executable commands. And what would be our customer, our client like? It will go to that network interface and it will just write in the log the message and the Docker file is the same. So we'll try and execute. We execute the server here to your left and it sends the messages and we see the client, it stays there. So we're in panic again. And why is that? Because when you generate a Docker container, it believes it's alone in the universe. It's waiting for somebody within that container receiving that message, but because our client is not connected to our server, it doesn't receive anything. So what's going to be our Superman right now? Docker Compose. With Docker Compose, we tell him that this client We're going to have two environment variables. One is going to be where the client will read this, what the server has given. And in the other one, it's the server where the message is going to be written. So the server over here is going to be translated into an IP. And Docker Compose links that server to an IP. And now we execute it, and as you can see, it works. Okay, round 4, we're going to introduce a Redis. So what's the architecture going to be like? We're going to have a server, we're going to have two clients. Client 1, we're going to have the same message as before, hello with one number, and in client 2, receive also the message, and each server has a Redis client to be able to connect. And in this scenario, we're going to do as follows. The server will introduce into the Redis service information. Our first customer, our first client, when I receive a message, which is a multiple of 3 to the counter, will go to Redis server and will recover the Goku information. And client 2, if the message I receive is multiple of 7, it will recover or retrieve the Vegeta information. So what will our server be like? We have two interfaces. Over here, two sockets. We're going to do push, and two addresses where we're going to be listening the address hi and the address sweetie. We're going to use Redis, and we set up a client, and we connect to a port and to the host where the Redis is. And if you see this process env, here, here, and here, it's going to be an environment variable that we're going to introduce into the Docker file. Our server, the good thing about Redis is that it's able to manage the data structure. And here I say that our key is going to be Goku, and power is going to be 1 million, and the same thing with Vegeta. And if you see down here, we have both the hola message and the sweetie message that we send to the hi and the sweetie. And each message is sent every 2 seconds. Our Docker file is going to be just like before. We will only add the library that allows us to manage this. So what will our client 1 be like? We're going to connect to the address, the hi address, and in our network client. And if down here we have multiple of 3, we will go and get the Goku key and bring it. If we have no error, we can show it. And the same thing with client 2. But in this case, we execute it within Sweetie. The address will be that of Sweetie. And here we have the multiple of 7, same thing. And what would our Docker Compose be like? In this case, we'll have our server. This is an improvement. We'll give a name to this container. We call it, and here, and this applies both to the hi and the sweetie addresses, and then the ports where we're listening. And the port will be Redis. And the image for Redis is a basic one that we have in the Docker Hub. And these ports, we have 2 numbers because the port of my Docker machine connects with the port of the local machine that's executed. And this depends on means that this server depends on Redis. Until Redis is not running, it does not begin. And with this link, we say there is a link with this component. Okay, customers, client. We have this environment variable, both for the Redis port and for the container and the address where we're going to do the pull. Client 1 does it on high and client 2 on sweaty. And our clients depend both on the server to listen through 0MQ and it also depends on Redis. And here we have how it works. As you can see, when client 1 has a multiple of 3 for the ORA message, we go to Redis and we retrieve the information we have about Goku. And here, when client 2 receives a sweetie message with a 7 multiple, we go to Redis and we take the Vegeta information in that case. And here, I also want to show you how it works. Look at the 21, is both multiple of 3 and 7. And when client 1 is multiple of 7, we go and retrieve that information. And the same thing here. So they are asynchronous. We receive it in both, and with both, we go to Redis and recover the appropriate key. Round 5, we're going to add Postgre to all of this environment. So what's the architecture like right now? We have our server here. Up there, and it will connect with a Postgre, which is also on a Docker machine. We have a client 1, a client 2, and a client 3. Clients 1 and 2 are going to receive the same messages that we've seen before, and client 3 is going to receive one more message, which is the one I've called end world, also with a number. So each one of these clients, based on the number of the message, will go to Redis service to get information. And if it's not there, it will go to the database and look for that information and send it to Redis. But let's see what circumstances we can find. First of all, the server goes to the database and brings information from 3 characters: Goku, Vegeta, and Piccolo. Client 1, when it receives a message which is a multiple of 3, just like before, it will go to Redis and retrieve information about Goku. But that information can have expired. And then it will go to the database and recover that information. Next, it will go to Redis and leave it there. And it will have a 10-second TTL. And if the Goku key has not expired, it will retrieve that. Client 2 will do the same thing, but in this case it's going to be multiple of 5. And with client 3, it's going to do the same thing with Piccolo. I want to show you the server here, because we have to add a library that we have from JS, which uses promises of JavaScript. So our connection is going to be through some environment variables, and here we use this library. Here we establish the connection, and here we have some PG helpers. Here I have a map of the fields I have in the database together with the name of the table, and with this multi-data I insert all of this data at once. You don't have to go insert by insert, you can do that straight away. And this is the connection, and this is the query. Insert data and the columns so that it knows exactly where to place them. And if we've had no error, we get that information through the log, and if there is a mistake. So what's our client going to be like? Well, it's very similar to what we had before. This part at the top is the same, and this part at the bottom is going to be what changes when it comes to connecting to the database. Here's the first checkup we do. We go into client 1 and 2, but client 3 is the same, and client 2 as well. So we have the Goku key exists, and if it does exist, no problem, but if it doesn't, it's here. We retrieve that information, and we go to the database, we retrieve that information, we put it in the screen and insert it in the Redis. And here at the end is when we have the expired, Goku expired. And here is where we insert it, and here's where we define its lifetime. And if it hasn't expired, we retrieve it directly. Okay, this is the Docker file of Postgres. I used the image of Postgres in the Docker Hub, and I've added a change. And with this modification, you copy a file that I've called init db.sh, and I included in the Docker entry point. And so when Postgres starts running, it sees whether we have an SH or an SQL file, and it runs it against the database. And this is our init db, and we are generating the model that we're going to create when it comes to inserting data in the database. So we have set up a user for that database, the database, and the model, a very simple table. But with this, we can generate any model we want for the database. Our server has changed a bit, and we no longer have the Redis access, and we've added the BG promised, and there are some details that I'd like you to note. And one of them is the wait for it over there, and the other one is the one we've mentioned, that will make it no longer acceptable, and the same thing happens on the client part.
So what happens when I see that everything is here? Oh, Postgres.
Cuando el servidor intentaba acceder a él.
And these brings out on the server when I wanted to access the server, so there was an error, and everything else just cascaded and didn't work. So this sorts out the beginning option that you choose, depends on also with links and volumes from. It doesn't ensure though that whenever a server begins, another one, or whenever begins, will be in ready state. So which tools do we have for this? We have the wait for it according to the official documentation. Here I use the wait for it in this case. How does it work?
La ruta dentro del contenedor donde lo tenemos.
We give it the root in the container, the service, and the IP. And when this service is raised, this command is executed. Likewise for the customer side. And there's an improvement here. We have an environment variable depending on the services. I have this Docker Compose, and I also have an environment variable file where we have the key and the value. And this is the result when you orchestrate and execute everything. For customer 1, 2, and 3, we see that they're waiting for the wait for it. And here we see the rest of the components and how they work. So whenever we have a message that is a multiple of 3, like here, so the customers are kind of mixed. Customer 1 got a hello. Goku is expiring Redis. He recovers that on the database and inserts it. The next case down is the same one. with the Vegeta customer. Here it is, a multiple of 5. And since this is executed every 2 seconds, from the multiple of 3 to the one of 6, only 6 seconds passed, and we recovered our Goku in Redis. Automatically, with Piccolo, the same thing happens. Since this is a multiple of 7, and Redis doesn't have that value, we recover it from our database. Okay. When we have message number 9, more than 10 messages passed since we inserted it, and the same thing happens as before. We go to Redis, we recover it and insert it. And here we have the Vegeta case. Okay. Another, this is very little in comparison with the idea I had in mind. So I need to work a lot on the container grid concept. We have a master node that we have mentioned, but we need to keep working on this master node to add many more things. So I'd like to develop a much more complex application to implement everything that has been orchestrated. And I like to play with Kubernetes, Docker Swarm, using Docker in the cloud, and maybe looking at the possibility of using Redis master slave database. Maybe I could use master slave database or add security. So if something may be improved, because I know there is a lot of room for improvement, but if you have any ideas, please let me know. And this is it, really. Thank you very much.
Preguntas, joder, no veo nada.
Are there any questions? I can barely see anything here. If there are any questions, please speak up. Okay. Just a final comment on Jacinto's talk. Like all speakers, Jacinto went through a call for papers. I didn't vote his speech to be included here. Why? Because I'm his godfather on the Fundación Princesa de Girona. It's the first time he comes to give a speech, and I thought it was important that he would be here for his own means. So please be on time when we come back at 3:30 after lunch. Thank you very much, everyone.